0 to 4 absolute value x minus 3 dx. And to do this problem, you have to first, because you don't know anything otherwise, is to graph the function. And then you draw vertical lines at x equals 0 and x equals 4. And then you calculate areas using formulas from geometry for, triangles, rectangles, squares, and such. Is that consistent with what you saw in class?
Yeah.
Okay, great. So this x minus absolute x minus 3, it literally it just tells you where it hits the x-axis. So it tells you that it hits the x-axis at 3 because there's a number 1 out in front. That's the slope. Okay, so your slope, it actually goes up to the right one, and then it mirrors it over here. It goes -1. So this slope equals -1, slope equals 1. That's how you want to graph these fast. So then you draw vertical lines at x equals 0 and x equals 4. And I see 2 regions there. Okay, so your area of region 1 is 1/2 base times height, because it's a triangle.
So 4.5.
4.5, and then area of region 2 is 1/2 base times height again, but this time it's 0.5, and then you add them together to get 5.
Okay.
So may I have you try this one on your own if you're okay with that? I know it's early. You win the award, of course, for getting that early math lesson in, but you can absolutely do this. Let's go absolute value x minus 1 dx from 0 to 5.
Just get some. So you just draw the lines at 5 and 0, right? And then
Yeah, because of this, you draw the line at x equals 0, and then this other one is x
so
equals
then
5. And you draw it till it
4,
hits, yeah.
Then it's up.
Again, that there's a 1 out in front of the absolute value, so that tells you the slope. So of the line, and then the negative of it tells you the other slope. And that's how you draw these quickly. Like I know in the past, like in algebra, you make a table, but you don't want to do that. It takes too long.
So the little triangle is 0.5.
That's right.
And then the big triangle is 8.
Okay. Sounds reasonable. So 1/2, 4 times 4. So that's 8. So the total area, this thing right here, like your final answer is
8.5.
8.5. Yeah. Okay. All right. So let's talk about like a little variation on this problem, just to remind you. So we're gonna graph a few things just so you can remember. Let's graph 2 absolute value x minus 2. So this one, the way you would graph this quickly is you would go to 2, okay? But this time, actually, let me change this to a 3. This time it's got a slope of 3. So you got to go rise 3, run 1, rise 3, run 1. So the over here, you have this line over here has a slope of 3. And then the other direction has a slope of -3. So down 3, right 1.
How do you know to do a slope of like up 3 over 1?
It's this number out in front. This
Oh,
tells you the
okay.
slope.
Gotcha.
And you may have intuitively learned that at some point, but it's never said because it's kind of a cheat. You know, it saves you from having to actually, you know, work it out. Okay.
So then why are you drawing that other triangle?
Because it has a slope of -3.
Oh,
And a V, like there's symmetry here also. You can see there's symmetry about this line, because the question you would be asked would be like the integral from 0 to 4, 3 absolute value x minus 2 dx. And this is one way to do it, probably
okay.
the only way. So you would have to find the area of region 1 and then the area of region 2.
Okay.
And we don't need to do that right now, but I want to show you a few examples like this, if you're okay with that, to kind of illustrate that. Now, this is where I have to ask, did your instructor tell you, and I'm going to use this as an example, the integral from 0 to 4, 3 absolute value x minus 2 dx, did he or she explain that this is the same as 3 times the integral from 0 to 4 absolute value x minus 2 dx? Did they tell you could basically bring this constant out?
Um,
And it's okay if they didn't. I just want to.
no, I don't think so.
Okay. Okay.
But we did do some examples where it was like 3 plus 2 and then an integral and then whatever.
Okay. All right. So let's do let's graph another absolute value here. So let's say I wanted you to graph the absolute value of x minus 3 plus 2. Okay. So do you recall that the vertex, the V, is at the coordinate, and its absolute value x minus h plus k?
Yeah.
So in this case, it would be at 3, 2. Okay, and then again, the slope here is 1. So you rise 1 over 1, rise 1 over 1, rise 1 over 1, so on.
Okay.
Okay, so let's say I wanted here the integral from 0 to 5, absolute value x minus 3 plus 2 dx, which is totally like reasonable, like to ask, because it's just shapes that you already know. How are you going to do it? Are you going to make trapezoids? Are you going to make a rectangle and 2 triangles? What do you see here when you do this? How are you going to cut it up?
Triangle and like, can you triangle square or triangle, 2 triangles and then a rectangle? Yeah.
Okay, so let's do that. 1, 2, and 3. Let's get this area, please.
So it's 2. 2 times 1, 2, 3, 4, 5. And then 1, 2. 2, so it's 14 plus 5 plus 2, 16.5.
Yeah, that's good. Okay, great. All right, so let me have you try one on your own here. Is that okay?
Yeah.
All right, and let's go this time. Let's go from 1 to 3. Absolute value x minus 2 plus 1 dx.
Okay.
Take as much time as you need to get the answer for that one.
Mhm. It's 2, 1, right? For the
It is, yep, and
Okay.
the vertex of the absolute value.
Okay. Two, two. Um, then 1, 2. Three.
Yes.
Okay.
Answer. Okay. Very good. So again, like we can, we should talk about a few more graphs here. I don't know how much this has been emphasized in class, but like, do you know what 4 minus absolute value x plus 2 now looks like? So I've made this very different than the ones that we've done before. And I mean, this is potentially the difficulty that you could have. So this could be rewritten as negative absolute value x plus 2 plus 4. And then the vertex here would be at negative 2 comma 4.
Okay.
And just let me know if there's anything you haven't seen before here or in a while. So negative 2, 4 puts us right there. Now, do you see this negative out in front? That tells you the
Yes.
slope is negative 1. So you always go to the right of it. So that means this slope is going down negative 1. And then this slope is going the other way. It's going positive 1. So that's how you graph these quickly.
Okay.
For that. So we don't want to do any integrals because like whatever I give you here is just gonna be more of the same, but we got to make sure you're comfortable with all these
Yeah, that makes sense.
variations on this. So let's do one more here. So let's have you graph 2 minus absolute value x plus 1. And then from here, we're going to find the integral from negative 2 to 2, I think.
Okay.
Let's just graph it first. So if you need to, you can always rewrite it as negative absolute value x plus 1 plus 2, and that has a vertex point at negative 1, 2.
So negative 1.
Actually, let me change this to 1. So the slope here, because of that negative out in front, that tells you the slope of this side, and then it has to v, so it's going to be the other direction there. So here's negative 2, and here's positive 1. Can we find the area between those 2 points?
Yeah, so it's negative 2 and 1. Is that what that?
Yes, yeah,
Okay.
yes. Let me clean that up in case you look at this later.
So you could do a square. And then 2 little triangles?
Yeah, now you may want to get comfortable with the idea that these half triangles, like this one right here, can actually go up here and make a full box.
Wait, what?
Okay. It's a little bit hard in the virtual. This triangle here
Uh-huh.
can actually move. You can actually move it up here. I don't know if you maybe done puzzles
Oh,
at some point in
wait,
your life.
but why can't you do a whole triangle? Like, isn't
Oh, you can. I'm just trying to show you like speed, like how to do it. Because this is a half, and this is a half. The whole thing is one, but I'm trying to show you that the whole thing becomes this blue. And maybe that's not clear at all.
so? But can't you just do like if you just draw a line at what's that?
Yes, -1.
No, like the other way, like horizontally.
That one.
Yeah,
Yeah, absolutely.
and then like a little one on the
Yes.
yes.
Yes, but like I want you to see that this is one half. Like I want you to realize that that's one half, and then these two up here are one half each, so they're a whole.
So what would the area formula be for that top one?
It's still triangle, but I'm trying to get you to like shortcut writing the one half base times height each time because they're each a half.
But how do you do it if you like? Can't you just write one half base on
Yes.
and do the whole thing? I don't
Yeah.
know.
Yes. Yes. You can do that every time. I apologize. I'm trying to give you shortcuts, and
But
you're not.
what would be the shortcut for that big one on top?
To see that it's one half. Each of the triangles is one half. So that this one is one half, and then this one on the
There's
right
no
is.
way to do it just like one formula, not like two times, is what I'm.
Well, it's just visually, you get used to like what the triangles, like you
Like, can't you just do one half? What is that? Two
times one. Yes, and that gives you one.
and that's the whole top.
That's the whole top.
Okay, that's what I was planning.
Yeah,
And
that's
and
fine.
then the little one is one half, one and one,
Yes,
so 0.5. And then the square is 2 and 1. So
that's right.
So it's 3.5.
Yes. Okay, so let's talk about another geometric shape that you're likely to see, if that's okay.
Yep.
I saw an example like that. So you studied this at one point, x squared plus y squared equals 1. And if we were to graph that, you would say, oh, it's a circle centered at the origin and has radius of 1. Do you remember doing that?
Mm-hmm.
Okay, so if you solve for y, you end up getting y equals 1 minus x squared square root, and then you get this plus or minus. But in your class, you're just going to see this. You're going to see the square root of 1 minus x squared. And if you graph that, you're supposed to recognize that this is a circle, and it's this part of the circle.
Okay.
Okay, it's also this part of the circle. So this right here, and that's what I want to make clear to start out is that when you go to this, it's the top half of the circle. The square root of this number, square root of 1, which equals 1, is the radius.
So then the number in front, or I guess it's not in front, the first number?
Yeah, the first number, yes. But it has to be in this form. Like it can't be in a different form than this for the time being.
Okay.
Okay, so the area of a circle, as you know, is pi r squared. But we're not doing a circle, we're doing just the top half. So you have to always cut it in half.
Okay. So pi 1, so it's 1 pi divided by 2.
Yes. So here's one question that I could be asked. Let me just give a little more. If I asked you, what is the integral -1 to 1 square root 1 minus x squared dx, the answer is 1/2 pi, but in words, it's the upper circle area. It's this part here.
Okay.
Like you have to calculate this number, but you have to know that it's this, because what I could also do is say, what is the integral from 0 to 1 square root 1 minus x squared dx? And this is now, so we know that it's this is the upper circle, but I only want it from 0 to 1. So in this case, it's the quarter circle. It's just this right here, because you start at 0 and you end at 1.
All right.
So this is the quarter circle, which would be pi r squared divided by 4. Or you can find the area of the whole circle and cut it into a fourth, which is the same thing, whichever way you like.
Okay.
All right, so let's try a different example here to see how clear this was. Because maybe it wasn't clear at all, and we'll just do better. So let's say I wanted the integral from -3 to 3 square root 9 minus x squared dx. So when you see this, you're supposed to say, oh, that's a circle, even though it doesn't look like a circle. You're supposed to say that's a circle, and the radius is the square root of 9, which is 3. But because it's positive, it's just the upper half.
So then it's 3, no, 9 pi over 2.
Right, so the area of a circle is pi r squared, but if you only want the top half, you got to cut it both in half. So it's pi 3 squared over 2, 9 pi over 2.
You just leave it as 9 pi over 2.
Yes, that's your final answer.
Okay.
Okay, so now let me give you one to try on your own. Let's have you find the integral from 0 to 4 square root 16 minus x squared dx.
So it's um 8 pi.
Yeah, so this is the equivalent of a quarter circle. So the whole
Well,
circle. Go ahead.
Wait, so it's a quarter, not a half this time?
Yeah, because we're going from 0 to 4.
Okay, so it's
So
not.
that was the little wrinkle there. Is yeah, the whole thing looks like this, but we only want.
So it's 4 pi?
We went from here to here. So just this region. Yeah, so maximize. Yeah, so you want the quarter circles. You want pi r squared divided by 4 this time. So 4 pi.
Okay.
Let's try another one here. Let's say I want you to go from -10 to 0 square root of 100 minus x squared dx.
So how do you know if it's a order or like?
So don't focus on the numbers on the limits here. Focus on what this graph looks like. And you can be as exact as you want, but it's from, let's just say that that's 10 to 10. That's 0, 10. That's -10, 0. Let's say it's 10, 0.
Okay.
The limits are the vertical lines. So we did this in the triangles and the absolute values. Let's do it again here. So there's minus 10 and there's 0.
Okay,
We want this region over here.
so it's quarter.
So it's a quarter circle.
So for the ones that were half, can you scroll up? So what did those ones look like again?
Sure. They usually have the same bounds on the top and the bottom.
Okay. So then it's 10 squared over 25 pi.
Yes.
Okay.
All right. So the instructor can do a lot of things here. Like one of them is actually move the circle, which the first way you could see it moved is you could just see it moved left or right. So like they could move it here and give you a graph like this. And I don't think you'll see this, but you should be aware that what moves the circle is, in this case, it's the square root of 9 minus parentheses x minus 3 squared. This is what moves it there.
Okay.
I don't think you'll see that. So but you may want to, ask or kind of get a feel. And I remember your instructor like piecewise functions from last semester.
Yeah.
And whether this is it or not. So the next thing your instructor seems to be doing here is like taking advantage of symmetry. And I'll try to explain what I mean by that. So let's say I tell you the integral of x squared from 0 to 1 dx equals 1/3. Okay, like that's going to be given. Do you recall that x squared is even?
Mm-hmm.
You remember what that means? And it means this, but graphically it means that it's reflected over the y-axis. Okay, so here's graphically what we just did. Actually, let me move this over here. So we found that the area here, this little curve right here, is 1/3. That's what this integral means. Now, because of symmetry, you should be able to tell me the integral from -1 to 0x squared dx is the same. It also equals 1/3.
Oh, that's so weird. Okay.
Yes. Okay. Now, like in time, you will know how to do it like directly. You'll be able to just sit there and calculate the integral, evaluate the endpoints, and like do it. But for now, like your instructor's saying, like, hey, like you can do this. So here's a couple of examples of that. So your instructor may choose to do something like this. They might say f of x is an even function. And they'll even tell you, comma, the integral f of x from 0 to 5 dx equals 15. And they would ask, part A would be, what is the integral from -5 to 0 f of x dx? Now, because it's even, that's what allows you to do this.
Okay.
We don't know. We don't know what this looks like. We have no idea what this looks like. Okay. But we know from 0 to 5, this area is equal to 15. But since it's even, it's mirrored over here on the left. So from -5 to 0, see how the limits are just like it's the same limits, but flipped, so
Yeah.
to speak.
So
It's
is the
all-
area also just 15? No, okay.
Yeah, yes. So the more you take math, like the more you have to just be like, well, that's the only number I've got. Like it must be that or something about like related to that number.
Mhm.
So then the next question that they could ask, and sometimes they would even not even ask A, they would just go right to B. They want to know the total area from -5 to 5. And you're supposed to know that it's double this
30.
initial. Yes.
Okay.
Okay, so here's another example. The instructor could tell you the integral g of x is even function. Actually, let's say they don't do it this way. Let's say they tell you, they don't have to tell you it's even. They could say, it is known that g of -x equals g of x. Okay, and that means this right here means it's even. Like they're encoding that into this. And they tell you the integral from 1 to 3 g of x dx equals 8. Okay, so now part A would be, well, what is the integral from -3 to 1 g of x dx? I'm sorry, -3 to -1. So this first one, they're telling you from 1 to 3. We don't know what it does, but we know that it has an area equal to 8.
Okay.
So because it's even, it's symmetrical. So over here, it's got the same picture, which I won't be able to draw, but its area is also equal to 8. Is that okay?
Yeah. Makes sense.
Okay, now this is the problem. The problem here is part B, you don't know how to do. If I asked you the integral from -3 to 3 g of x dx, this is unknown because we don't know what's happening in here. Like what's happening in this region? What is happening from -1 to 1? We don't know. Like it's not given. So there's some limitations there. If you, like in the previous example, I said, oh, it's from 0 to 5, or it's from 0 to 1. Then you can go -1 to 0 or -5 to 0. But if there's a gap, you don't know what's happening in there.
Right. Okay.
Okay. So now out of sine and cosine, do you remember which one is the even function? So here's cosine. And here's sine.
So
This is cosine. So which looks the same on the left and the right of the y-axis?
cosine or
Yes. So cosine is even.
wait, but they both look the same.
Sine is odd. Sine of x is odd. See how it's down here. Sine x is odd. We're going to talk about odds, but so do you see how it's mirrored? Like this is the mirror. It looks the same.
Oh, because yeah, okay.
Okay, so this is a good one. So they maybe will tell you the integral from 0 to pi pi over 2 cosine x dx equals 1.
Okay.
No. Sorry, let me check this because your notes seem wrong, and I want to give you some bad information here, from 0 to pi over 2. Okay, yeah, this is correct. All right, so now if I asked you part A, if I said, what's the integral from minus pi over 2 to 0 cosine x dx, because it's even, what would you say?
1.
It's also 1. So now, like, to summarize, to do them together here, what is the integral from minus pi over 2 to pi over 2 cosine x dx?
2.
1 plus 1, which is 2, yes.
Wait, so were my notes wrong?
Your instructor chose this weird example. Let me look at it carefully. No, that's right.
Okay.
Yeah, that's right. It just did look wrong at first. Okay, are you comfortable with evens? Because we got to talk about odd
Yeah.
functions now. Okay, so let's look at a much more basic odd function so you can see this. Y equals x is an odd function, and it's because f of minus x equals minus f of x. That's like a definition. The word, though, or the symmetry that we often say, is it's got origin symmetry or point symmetry, and it's a rotational symmetry. So I'm using a lot of words, but you'll when you see it visually, you'll agree here. So the graph of this, so like if this top part were in red and it were rotated 180 degrees, you would get the bottom.
Okay.
Do you remember that from previous classes?
Yeah.
Okay. All right. So we've already done this example a lot, but let's just do it again in this context. The integral from 0 to 1 x dx equals 1/2. And what that is it's the area under the curve from 0 to 1, this little triangle here.
All right.
So you already know that's 1/2. What is the integral from -1 to 0? So now x dx. Now this is different. See how it's now the area below the x-axis?
Mm-hmm.
So its area is -1/2. Because the area is 1/2, but it's below the x-axis. So the area is equal to 1/2, but below.
How do you know that one's odd though? Just by like looking at it?
Yeah, because you can also do this test up here of f of negative x equal to negative f of x.
But like if you give like the integral.
So you're looking at this function inside the integral.
Uh-huh.
And that's how you would know. Like, and we get let's do another example after this to explain that. But it's do you agree that it's also 1/2, but it's negative because it's below? Is that okay?
Yeah.
Okay. So now that's part A. Part B would be, what is the integral from -1 to 1 x dx, and it equals -1/2 plus 1/2, which equals 0. And that's because the area above and below is the same.
Okay.
So let's try to answer your question, which is like how to figure out whether it's an odd function or not in the context. So let's say we look at y equals x cubed. And what this really means is f of x equals x cubed. So to figure out whether it's odd or even, the first thing you do is you put negative x in for x. And then on the right here, you cube it. So it becomes negative x cubed. And then you first ask, you say, okay, is this the same as the original? And the original was executed. And the answer is no. If it is the same, then it's even. So since it's not the same, you factor out -1, which is kind of already done. Like there's already a -1 in front, but you factor out a -1. So it's -1 times x cubed. And is this the same as the original?
E-
And the
Yeah.
original is yes. And that tells you that it's odd.
Oh, okay.
So that's your test. That's how you know. But you'll start to like remember which ones are odd and even. But that's important here. It's important here. So the fact that this is odd helps us out here. So if I said, okay, what's the integral from 0 to 2 x cubed dx? And I tell you that the answer is, let me think about this, is 4. Okay.
Okay.
Because it's odd, you're supposed to know right away that the integral from -2 to 0 x cubed
-4.
is -4. Yes.
So then 0 from.
Yes. So if we wanted the integral from -2 to 2, x cubed dx, it's 0 because it's odd. You don't have to do anything to get it.
Yeah.
So again, the way this would work is you'd be given an example. Your instructor would say, f of x is odd. No, I'll make that one up next. Is odd function, and the integral from 0 to 8 f of x dx equals 3. Part A would be what's the integral from -8 to 0 f of x dx, and you would say, oh, it's -3. And then part B would be, well, what's the integral from -8 to 8 f of x dx?
3.
Minus 3 plus 3. It's 0 because it's odd. Because it's odd.
Right. Okay.
Now it could also be, let me give you another example here. It could also be written this way. G of x, I'm sorry, let me not write that. G of -x equals -g of x. Okay, and this implies odd. And the instructor could tell you, they could say, okay, the integral from 0 to 4 g of x dx equals -2. Now this time it's different. Like it doesn't have to be always be positive on the right here. It could be, but it's not. But part A would be, well, what's the integral from -4 to 0 g of x dx? So it's the opposite sign of this. So it's 2. So it's 2.
Right. Okay.
And then part B would be, well, what's the integral from -4 to 4 g of x dx, which is 0. Okay. Okay, so let's try a couple problems here. See if you can do this. All right, so the integral from 0 to 2 f of x dx equals 3. The integral 2 to 5 g of x dx equals 4, and f of x is even, g of x is odd. And I could ask you a bunch of questions. I could say, well, what's the integral from?
Wait, so would they tell you that it's even or odd?
Yeah. In this case, they have to.
Okay.
So this one is just what's the integral f of x dx from -2 to 2.
Okay, so it's 6.
6. Okay, now again, like some of these things matter. Like if I just ask you for the integral from 0 to 5, I'm sorry, no, I can't do that. Actually, this was a bad example. I can't do anything more with this one. So let's go back to sine and cosine. So if you look at the graph of sine x again, sine x comes up, goes down, comes back up, goes down, comes back up. Sine x is odd.
Mhm.
So if I tell you the integral 0 to pi sine x dx, if I tell you that that equals 2, and that's this region right here, you can immediately tell me that the integral from minus pi to 0 sine x dx is
-2.
-2. Yeah. Now, based on that, could you tell me, this is slightly new, what's the integral from 0 to 2 pi sine x dx? So these are the same. So this -2 over here is this red area on the left,
Yeah.
which is the same as this red area on the right. So this black area is 2, this red area is -2, and that's 0.
Oh, okay. So you just,
Yes. All right. We didn't do, I think we can just really quickly, we can always pick up here next time.
well, and then for that last one, from -pi to pi is the 0, right?
Yes, that's right. That's right. Okay, so really quickly here, I probably don't have enough time to this, but let's say I want the integral from 0 to 4, 5 dx. So this right here is your function. Your function is y equals 5.
Okay.
So what does y equals 5 look like? It's a graph of a horizontal line of 5. So from 0 to 4 is literally this rectangle here.
Yeah. You just do the area of the rectangle?
Yep.
So 20.
Yes.
Okay.
And there's more examples we could do on this, but probably a good place to stop there for this. I'm going to stop the screen recording, but could you just hold on for just a moment, please?
Yeah.
All right. There it is. Stop.